Hey everybody, welcome back. We're moving forward into the last part of this unit. So we were earlier creating polynomials out of different kinds of roots, irrational, imaginary, integers. Today we're going to find all of the roots. To do this, we're going to remember some stuff from Unit 4. And to start that reminder, we're going to do basic long division. So we're going to divide 570 by 5. Here we go. So first of all, we're going to look at the first numbers. And we want to know how many 5s can I put in a 5? Well, just one. And then we're going to multiply that 1 to the 5 and subtract it away. So there's nothing there. Normally you might put a 0. I'm not going to put anything, just because it's going to match what we do later. And then we're going to bring down the next number and do the same thing. We can put one of those 5s into a 7. Okay, so 1 times 5 is 5. And then we're going to again subtract. 7 minus 5, and we're going to get a 2. We're going to bring down the last number. It's a 0. And then 5, how many can I fit into a 20? I can fit 4 of them. 4 times 5 is also 20. And if you were to subtract that away, there would be nothing, so there's no remainder. So that's your answer, 114. Okay, so look back through how it happened, how we did it. And this can help you to remember, bringing things down, multiplying. This can help you remember the process from when we do this with polynomials, because it's back. Polynomial long division is back. So we're going to set this up, and while we do, some of you may be saying, wait a minute, we did this with synthetic division too, didn't we? We did, but most of the ones you're going to see today, you cannot do with synthetic division, or not really, not without a lot of weirdness going on. Now, as we're setting this up, notice that between these two numbers, 30x cubed and negative 9x, something's missing. Okay, it would be like having a 0 missing and just calling it 57 on the earlier problems. A placeholder, a 0 is missing. So we need to fill that in with an x squared. That's the missing term. And then we can keep going. If you don't have that 0, it's kind of like saying, oh, 57 is the same as 570, and that's not. So you should be able to count down on the exponents. All right, so now that we've got it set up, we are going to put the x plus 5 out in front, so it can go ahead and divide. And yes, this could be done synthetically. But again, the problems, especially on the back of your worksheet, they cannot be done synthetically unless you get really crazy about it. So this is actually the easier way. All right, we're looking at front terms. We want the x to match 5x to the 5th. So we need x's and a number. So if we have 5 x's, and basically we need 4 more of them because we've already got an x out in front. Okay, we need the number 5 to get to a 5. We're going to multiply just like we do in the other process when we do it with normal numbers. The catch here is that there's 2 numbers there. We're going to multiply by both of those numbers. Okay, so 5x to the 4th hits x and the plus 5. And then we subtract all of it, not just the 5x to the 5th. So 31 minus 25, and we get 6x to the 4th. So remember, you're subtracting all of it. Don't lose that negative out there. And then just like in the other problem, we're going to bring down the next number. Okay, just like that. And again, we're back to looking at first terms. First terms only. Okay, so don't worry about the 5 or the 30. They'll take care of themselves. First terms only. So hopefully we're going to get this to match. So 6x cubed times an x is 6x to the 4th, like that. And then we're going to times it by a 5 and get 30x cubed. Okay, and this subtracts again. Okay, now the problem with this one is that when it subtracts, you get a whole bunch of zeros. Now you could call that 0x cubed and keep going as normal, but there is a shortcut when you start running into zeros, and you can start filling in zeros. That gets a little tiresome though, so basically you can start bringing down numbers until you stop getting zeros. So the next number we get that is not a zero is a negative 9x, and that's going to become our new first term. So this is the shortcut when you're dealing with zeros. We want that, again, to match this guy. So how do I make an x turn into a negative 9x? And the answer is with just the negative 9. That's all I need. So negative 9 times x, there's that negative 9x. You do have to distribute to both of them. Negative 9 times 5 is a negative 45, and then we'll bring down that last negative 45. Now, if we did this right, the problems on your worksheet should not have remainders today. We've dealt with remainders in the past, but today they're not going to have remainders. So we should get an exact match that when you subtract, totally cancels out. So the answer to the division problem is that thing on top. It's kind of spaced out funny because I put the exponents over their like terms because it helps you track the exponents. Because we're missing those 0x squared and the 0x, you can put them in. It's not wrong if you do in the answer, but if you want to match the answer key, that's what it's going to look like without the placeholders. Polynomials, in the end, not as concerned with placeholders as real numbers are. Okay, we're going to try this one more time. And we're going to have a slightly more complicated problem this time. And by complicated, I'm kind of misleading. It really isn't that complicated. What makes it seem complicated is there's more numbers and more terms running around. So we're going to set this up. Okay, again, you should be able to count down the exponents, and it doesn't look like we have a need of any placeholders. Now here's the part that's going to be a little bit different, this part out front. X squared plus 2x plus 5. That's no longer a binomial. Okay, so it's a trinomial. And this is where it is very hard to do this with synthetic division. So again, don't worry about the 2x and the 5. They'll take care of themselves. All you need to worry about are the first terms of each. So x squared, how do I make it 3 and x to the 4th? Well, for the x squared, to become x to the 4th, I need 2 more x's, so that's another x squared. And for a hidden 1 to be a 3, you need another 3. Okay? And keep in mind, we are multiplying. Okay? Once you've got the thing on top, a lot of people get stuck, and they're like, I forgot what to do with that thing on top. It multiplies. It distributes out to the front number, and it hits everybody out there. So the x squared, the 2x, and the 5. And here we are coming up with that answer. Okay, so 3x squared hit x squared, and it hit 2x, and it hit 5. We got that thing. Okay, the next stage is, again, if you need to look back at normal long division, we're now going to subtract that thing. The subtraction doesn't come naturally. You put it there. So subtract those, nothing happens. 16 minus 6, you get a 10 with an x cubed. And then 27 minus the 15, and that should be a 12. And it's positive because 27 is the bigger number and he's positive. And then we're going to bring down the 34x. Okay, and you should have 3 terms to match the trinomial in front. Just like on the last problem, you had 2 terms to match the binomial in front. All right, x squared. You want to get that x squared to match a 10x cubed. Well, an x cubed, we've already got an x squared. That means you need 1 more x, and you just need a 10. So the number part is easy. We're just matching the front number. Mainly because 10 times 1 is going to be itself. All right, this thing is going to distribute. Make sure you hit all of them. 2, 20 placeholders, And then 10 times the 5 is going to pick up a 50 there. All right. And then we're going to throw in that subtraction. It doesn't come on its own. You then say, I will subtract, and put a subtraction sign down. Okay, remember all of them are subtracting. 12 minus 20 is a negative 8. The signs are really important. 34 minus 50 is going to be a negative 16 with an X. And we're going to bring down the last number, which means we're on the last cycle. Okay, each cycle repeats itself until you're getting to the last number. And each cycle follows the same pattern. So once you've got the pattern, you're just repeating it. First terms, it's the start of the pattern. We need x squared to get a negative 8x squared. Well, we've already got the x squared, so all we need is the negative 8. Okay, next part of the pattern, the negative 8 hits the front and hits all of them. Negative 8 hits 2x, it's a negative 16x. Negative 8 hits 5. Remember that negative, don't lose it. And we get a negative 40. Now, if we did this right, we should have an exact match. And what happens when you have an exact match is when you put that subtraction sign out there, it changes all the signs so they cancel. So negative 16, and the bottom 16 is now positive. It cancels. Negative 40, negative 40, that's a positive. So negative 40, positive 40, that also cancels. So there should not be a remainder. No remainder. There is the answer. That's what happens when you divide those numbers, or those polynomials. All right. Again, the reason the synthetic doesn't work is synthetic, you need something to plug in. Okay? So over here, the x plus 5, you could then say, oh, a root is negative 5. I can plug that in. But here, it's a little, it's really deceptive as to what could I plug in. So there's nothing to plug in, and that's why a trinomial is easier if you just use polynomial long division. All right, the first part of the notes that we've done should cover the front of the worksheet. This is now the new stuff. This is the back of the worksheet. They've given us a root and a polynomial. We've done this before. Again, this is also from the end of Unit 4, but we've never done it with a complex number, which is a number that has the I in the back. Now that I is a radical. Radicals actually have two parts to them, the plus and the minus. So in giving us one root, they actually gave us two roots. We can create the second root. Part of our instructions are to factor, but the other instructions are to find all the roots. If you look at the highest degree, it says that's a 4. There are 4 answers. In giving us 1, they've actually given us 2 of the answers. X equals those 2 answers. The problem is it also equals 2 more things, because our highest degree is x to the 4th. So there's actually 2 more things that can equal. So what we're going to do is something very similar to 6, 7. We're going to take the 2 answers we have, and we're going to build a polynomial out of them. Okay? We want those answers to get back in with x. So they do their opposites, x plus 2 and then minus 3i from the front number, or from the top root, the one they actually gave us. And then to get that negative 2 over to the x, you add it over to the x. And then to get the negative 3i over the x, you also add that over. So you can also think of it as putting them back over with the x. Okay, and remember also from 6, 7, there's a shortcut we can use. If you group the front 2 terms, you've got conjugates. You've got front conjugates and back conjugates. Well, you get the front, you can times the front 2, and you can times the back 2. Remember, we've called the front 2 terms very technical definition of thing. So that right there, that's thing times thing. Minus 3i times 3i is a 9i squared. Okay, now x plus 2 times x plus 2, thing times thing, those are not conjugates. Conjugates need opposite signs in the middle, and these don't have it. So we have to do a full FOIL on this. So x times x is x squared, times the 2 is the plus 2x. 2 times x is 2x plus 4. That's 2 times 2 in the back. I squared is a negative 1. That will make a plus 9 from that back term that we multiplied. And then all we have to do is combine like terms. So we get x squared plus 4x plus 13. Okay, that's a polynomial that was made from the answers. Okay, it's also a polynomial that is related to the original. Okay, in theory, we could get 2 parentheses and times back to the original. Okay, x squared plus 4x plus 13 times something else equals the original polynomial that we were given. Okay, so the roots help us find something that can times into our answer. The problem is we're missing the other something that times into our answer. So to find the other something, we're going to divide the thing we did find. So we found x squared plus 4x plus 13. We know that that times something else equals the original polynomial. What we want to find is the something else, because the something else will have the other 2 roots. So the first 2 roots are in the x squared plus 4x plus 13. The last 2 roots that we don't have are in the missing factor. So we're going to divide this to find the missing factor. Okay, x squared times x squared will get us the x to the 4th, and then we need a 2 to get the number. Remember, you're just doing first terms, but when you multiply everybody. So we get 2x to the 4th plus, and then we're going to get an 8x cubed, so watch your exponents, plus a 26x squared, 2 times 13. Okay, and then we create and introduce a subtraction sign. Subtract the first 2, they should cancel. And then 15 minus 8 is 7x cubed. And then we're going to do 39 minus 26. It's a positive 13x squared. And then we'll bring down the next term. All right, back to first terms. So every time you bring a number down and you finish a cycle, you go back to first terms. That's the start of the next cycle. Follow the same pattern. So we want x squared to become 7x cubed. We need the 7, and looks like we just need an x to get up to the x cubed. Once again, here's the next step of the pattern, is you distribute that number you put on top, you distribute it to the front number. So we get 7x cubed. We're going to get a 28x squared. And then 7 times 13, we're going to get a 91x. Okay, and with these numbers, here's kind of the last part of the pattern. So first terms, distribute. Last part of the pattern is to subtract. Remember, you're subtracting all of the bottoms, so that's going to be a negative 15x squared. 13 minus 28, and then 31 minus 91 is a negative 60x. Be very careful with the signs. This is an easy place to mess up. Negatives on the 91 is bigger, so your answer is a negative 60. Bring down the very, very last number. Okay, restart the cycle. Look at first terms. Okay, so first terms, how do I make an x squared turn into a negative 15x squared? Well, probably with a negative 15. Okay, and we're turning it into a negative number. We want an exact match. That negative there, we want it to match. And we're going to times it to everybody, distribute it to everybody. Okay, negative 15 times 4x is usually a negative 60x. And then negative 15 times the 13, that is usually a negative 195. And if you did this correctly, you should have an exact match that when you introduce that subtraction sign, everybody should start canceling. Because the negative will basically change all the bottom row signs so that they cancel their counterparts. Okay, so this answer that we have on top, if you times that answer, the 2x squared plus the 7x minus 15, if you times that with the thing on the left, you should get the original polynomial. So go back to the basic one. If you take that 5 and you times it by the answer from the top, 114, you get the original polynomial, or the original 570. Okay? Same thing's going on here. X squared plus 4x plus 13. If we times that by the answer we got on the top, we should get the original polynomial. So what we've done is we factored the original polynomial into two things that multiply to get it. Okay, these two things, if they multiply, they will get the original polynomial. The first of these two things has the first of the two roots that we came up with. Okay? So we're done with him. We know what his two answers are. The other two roots we're looking for, they're in this new polynomial, 2x squared plus 7x minus 15. Okay? And what we need to do is we need to factor it to find the last two roots. So we're going to run slide divide here. Slide divide sometimes comes with another slide. So we're going to review how to do slide divide. Okay, slide divide means in the beginning you take the front number, which is a 2, and you times it into the back. You basically slide it into the back and multiply. Okay, so we have x squared plus 7x minus 30, and this is what we're going to factor. Okay, we need things that will times to 30 and subtract to 7. The x squared part's easy. We're just going to put an x in each parenthesis. But in the back of the parentheses, what can multiply to 30 but subtract to 7? So we have 1 times 30, 3 times 10, 2 times 15, and the only group that subtracts to 7 is 3 and 10. So one of them has to be negative because they still need to times to a negative 30, but the 7's positive. So we should probably put the positive on the big guy, so we can go 10 minus 3, and then 10 times negative 3 is negative 30. Okay, we did the slide. We now need to do the divide. That number we multiplied into the 15 was a 2. We have to divide it back out. Okay, so it's kind of like in parallel circuits. You flip it going in, but then you have to unflip it coming out. Same thing. We times going in, we have to divide coming out. If it doesn't divide, so the 2 went into the 15, it now comes back out of those back numbers. If it doesn't divide, 3 over 2 doesn't divide, you slide it to the front. But if it does divide, 10 over 2 does divide, then you just get an answer. Okay, we're going to bring down x squared plus 4x plus 13. Okay, he doesn't factor anymore. His original factoring contained i's. Okay, you don't want your factors to contain i's. So this guy does not factor unless you want to get i's involved. Okay, so this is the complete factor that was part of our instructions, was to factor the polynomial. This is the complete factor. There's the one that doesn't factor anymore, and then the last two that we factored with slide divide. Okay, final part. We're going to find all the roots. We already found 2 of the roots. Okay, so 2 of the roots from the very, very beginning was that negative 2, and then the plus 3i and the minus 3i, which I'm just going to leave as a single answer like that. Okay, and there's 2 answers in that because its highest degree is 2, so it's containing 2 of our roots. This guy's got 1 of our answers. Remember, you're looking to cancel, so a negative 3 is canceled by a positive 3. But we also have a timesing 2. To get rid of it, you go back to the slide divide. It's really a dividing 2. Okay? If you were to plug that in, the top 2 would hit the bottom 2 and cancel, and you'd be left with a 3 minus 3, which would equal 0. Okay, last root is in the last parenthesis. It's a positive 5, so you grab a negative 5. The x doesn't have anything in front of it, so we don't have to worry about that. And this is the complete answer. You have the factoring, okay, the one that the weird one with the i's and the other 2 factors, and then we have all of the answers, all of the roots, and we have completed the problem. All right, finally, we are on to the second example that will help you out on the back. This example is a little bit different. It's got some negatives throughout. The last example only had a negative at the very end. Once again, they have given us a root. But in doing that, they actually gave us two roots because there's also a 3 minus I. The complex conjugate is the other root. Okay, so the radical part, that's the part with the plus and the minus in front of it. Okay, only the radical part. Okay, so whatever's in the radical term. 3 in the front does not change sign. That's not part of the conjugate. Okay. All right, so we've got two roots. With these two roots, we're going to make one of the groups that is a factor of the polynomial. So x equals these two roots, and if you want to think about it, to get them over with x, you have to subtract over 3, and for the top one, you subtract over the I. So minus 3 minus I. You can just put them in as opposites, but if you kind of want to figure out what the algebra is doing, that's what's going on. So to get it over with the x, x minus 3, and then the second one, x plus I, to get them over there on the same side of the equal sign as the x. You can think of it that way too. Alrighty. So now that we've got these in with their x's, I mean, technically these are factors of the polynomial, but these are weird factors. So let's make them more normal. So again, I'm going to group the initial two terms as thing and thing. We have thing minus I and thing plus I, which means we have conjugates. So we have thing times thing and negative I times positive I. So thing times thing looks like x minus 3 times another x minus 3. And then negative I times positive I, it's going to be a negative I squared. Okay, x minus 3 times x minus 3, those guys are not conjugates. Okay, so we have to FOIL them out. Okay, conjugates require opposite signs in the middle. They don't have. So I'm going to FOIL it over here to the right. So x squared minus 3x, and then there's another minus 3x and a plus 9. So that's what that gets. And then a negative I squared is like a negative 1, so it's plus 1. Okay, and then I'm going to come over here and write down what it looks like when you've combined the like terms. You get x squared minus the 6x, and then the 9 and 1 is a plus 10. Okay, that's a friendlier group than these funny parentheses with i's in it. So you want the factors, the groups within the parentheses, you really don't want them to have i's because that's just kind of weird. All right, now we're going to take this group that we found and we're going to divide it into the original polynomial to find the other group, because the other group has the roots or the answers that we're missing. So two of the answers, 3 plus I, 3 minus I, we've got them. But the other two answers are missing, and if we find the other group, we can find the other answers. All right, so here comes the cycle of polynomial long division. We start with first terms. X squared needs to become 5x to the 4th, so we need another x squared, and to make it a 5, it's got a hidden 1, probably just need another 5. 5 times hidden 1s make more 5. So if your lead term is a hidden 1, that's just really nice. Remember, we are distributing that guy. So once you have somebody on top, you distribute it. And that's the pattern you'll keep doing. Watch for negatives, okay? Be very careful with the negatives in this. And then 5x squared times 10 is usually 50x squared. If it's not, then the universe is doing something strange. All right, we're going to subtract off the entire group, and because we've got negatives throughout, that's going to be a little stranger than the last one. So we have a negative 38, but that 30 is positive. When you subtract a negative, it's really positive. So it goes negative 8x cubed. 94 minus 50 is a positive 44x squared. Okay, 94 is bigger, so the 44 is positive, and then we're going to bring down the negative 56x. So we have three terms to to match the trinomial that we're dividing. Okay, new cycle, first term again. Okay, x cubed, we have an x squared, so we probably just need an x, and then we need to match a negative 8. The negative is critical, so you need another negative 8. You want an exact match. So this guy will multiply, and he will distribute, okay? And be really careful with the negative signs as you're doing this, okay? So we're going to get a negative 8x cubed, and then we're going to get a plus 48x squared, okay? And the plus is coming from that negative 8 times the negative 6. That's where the positive is coming from. So be very, very careful with the signs. It's an easy place to make a simple mistake, even if you've got the rest of the concept correct. Okay, so just be careful with that. And then finally, we have a minus 80x. All right, the big group is subtracting. This is kind of the last part in the cycle. Remember that subtraction, it applies to the entire bottom row. So we have a 44 minus 48. Double negatives on the 80, that's a positive 80. So we end up with a plus 24 once the 56x is subtracted off. Okay, and then we bring that guy down. First terms again. And we brought down the last number, so we are on the last cycle. First terms, probably just need a negative 4, and it should match perfectly. Okay, negative is about to hit negative again. Be really careful with that. Plus 24x with that. Negative 4 hits 10, and that is a negative 40. If we did this right, we should not have a remainder. And doesn't look like we're going to have one. If that whole group is subtracted, all the signs change and they will cancel with their counterparts above them. Cancels, 24 minus 24 cancels, negative 40, and then minus minus, so it's positive, negative 40 and a positive 40, they also cancel. Okay, we have two groups now. Okay, we're going to use these two groups. This group has not yet been factored. It has our missing two answers. Okay, the group we had originally, we used the two answers to make it. And then this new group has the remaining two answers that we don't have yet. So this 5x squared minus 8x minus 4, it contains the remaining two things that x can equal. Okay, we're going to factor this. We're going to use slide divide again. Okay, so first of all, we're going to slide the 5 into the very back because it makes it a lot easier to factor. Okay, so there's that slide. And when you slide, you multiply. Okay, then we're going to factor, and the reason we're sliding is so that we don't have a front term. It's harder to factor with a front term. X squared splits into x times x, negative 20. We need things that multiply to negative 20, but they have to subtract to get 8. And don't worry about the negative quite yet. So we've got 1 and 20, 2 and 10, 4 and 5. 2 and 10 are the only pair that subtract to get an 8. Okay, to get a negative 20, one of them has to be negative. And since we're subtracting to a negative number, it's probably the bigger one that's negative. So 2 minus 10, that is negative 8. And 2 times negative 10, that's the negative 20. But we slid going into this. Kind of like parallel circuits, we now have to unslide. So to unslide, we slid multiplied, so we're going to divide slide to get back out of that. We divide with the same number we used to multiply. Okay, and some of these will actually slide. Some of these may not slide, though, because it may actually work. 2 divided by 5 does not work, so the 5 slides back to where he should be. 10 divided by 5, that works, so we don't actually have to slide on that one. So we get x minus 2, and that's the factor. That's the factor for 5x squared minus 8x minus 4. All right, we're going to bring down the original factor that we built out of the imaginary guys. So the original factor was x squared minus 6x plus 10. Okay, so all we did was we brought that guy down to right there. So these three groups times to get the polynomial. And x equals from that first thing, we know what that equals. Okay, those were the two roots we were given in the beginning. But these two back groups, these two back parentheses, they have our other answers. So plus 2 goes to minus 2. There's a timesing 5, and that will become a dividing 5. So if you were to plug that in, top 5 hits bottom 5 and cancels, leaving you with a negative 2 plus 2, and that's where the 0 comes from, because all of these things, when you plug them in, go to 0. Okay, last parenthesis, that one's the easy one. Negative 2 goes to positive 2. So those are the answers and the factors. So the back of 6/8 is going to ask you for two things, the factors and the roots, or the zeros, or basically what does x equal when all of this is set to 0.